All right, so this lesson is going to be covering sections 5.1 and 5.2, and it's on rational functions, graphing them, and finding asymptotes. Okay, so on our notes, we have notes for 5.1 and 5.2, and I kind of like these 5.2 notes better than the combination 5.1, 5.2. So these are all already on your, if you want to get them off of pages, okay, in your study notes. But I'm just going to talk through 5.2, and then we're just going to do some examples. And then I will give you an assignment to work on that has 4 problems, okay, and that will be your 5.1, 5.2 review assignment that you need to turn in to me. All right, again, look on the syllabus I sent you last week if you need to figure out the due dates on each of those. So we'll have our first meeting on Tuesday of next week. I don't think I have that exact date with me. Maybe I do here. Let's see. Tuesday of next week, which would be April 7th. And that is when we'll talk about sections 4.2, 4.3. And then on April 14th, we'll go through questions on 5.1 and 5.2. All right, so just be sure keeping up with the assignments in your math lab. So let's get started with 5.1. So the first thing I want to do is just, and 5.2, we're just going to talk about them together, okay? So on the 5.2 notes, I just like how these are written out better. So what a rational function is it's when you have a polynomial in the top numerator and a polynomial in the denominator in both, which means you're going to have a value of x, whatever the power is in the top, and a value of x, whatever the power in the bottom. Okay, so it's a polynomial over polynomial. So from there, to talk about an asymptote. So an asymptote is a line that goes through your graph. It's a linear line, and it's a line that your graph will never touch or cross. All right, so it's undefined at those points because your graph will never reach that point. You will get closer and closer and closer, but never touch it. And that's what an asymptote is. All right, and you'll get a better idea when we go through the notes. So a vertical asymptote, which is going to be straight up and down, okay? You can find a vertical asymptote by setting your denominator equal to 0. All right, so that's how you want to write your notes. You set your denominator equal to 0, and that's your vertical asymptote. Okay, so if I look up here at the notes, notice this power is an n and this one is an m. Okay, so if I look here at the second bullet, if n is less than m, so it's saying this power is less than this power. So let's say I had a 3x squared over 5x to the third, something like that, okay? If this number, this exponent, is smaller than this exponent, then you have a horizontal asymptote at y equals 0. So it's really the y-axis where that asymptote would be, all right? So if n equals m, if these two powers are exactly the same, like 3x squared over 5x squared, then you're going to have a horizontal asymptote that's going to go this way. It's going to be horizontal, and it's going to be whatever this ratio is. So maybe this ratio is 2 over 3. So at y equals 2/3, you're going to draw a horizontal line. And we'll go through these so you understand them a little bit better too. Okay, now if this n is larger, if this n is larger than this m, okay, then you don't have a horizontal asymptote. What you're going to have instead is a slant asymptote. All right, so that's going to lead us down here into talking about, well, maybe I don't have the slant asymptotes on here. So let's look here. Let me give you these notes. We have 2 sets of notes. So a slant asymptote, which is also called oblique, okay, it can be both. You can see right here, slant or oblique. And so all we do on that is we divide our denominator into the numerator, and whatever we find as our answer without the remainder is our line. So it's going to be like a straight linear line, but it's going to be slanted. So we'll talk about this some more. So I don't want you to panic if you're not getting it as I talk through it right now. All right. So also we can have holes. And that just means there's a hole in your graph, so it's not continuous. There's a part in it that's discontinuous. And so if I can factor out the numerator and I can factor out the denominator, and they have a common factor, like maybe they both have an x plus 5 in the top and in the bottom, then I'm going to have a hole wherever that factor is set equal to 0. Again, we'll go through some problems like this so you understand what I mean. So the process for graphing rational functions is you want to find the x and y intercepts. Okay, and I'll show you how to do that. Then you have to determine if there's a vertical asymptote, if there's a horizontal asymptote, or maybe a slant asymptote. Okay, then you draw your asymptotes and you pick a point from each region and find for x and find what the y value is. And then you sketch the graph. So like I said, we're going to go through a lot of these problems, but just looking at these notes, I like these notes better, that this 5.2 notes better than the 5.1 and 5.2 combined. So I think you might want to look at both of them, but these can take you back if you have questions on the order on how to do things. Okay. All right. So let's take a look on the study guide. I'm still going to go through your questions on the study guide that we have. So starting with 5.1, okay, the first problem. So the first problems are on here, and I have them on a separate sheet of paper. So I want you to recognize that these are your notes, 5.1 notes. This problem we skipped. Okay, I'm just going to go right to this problem. And this is the one that I'm going to start graphing. So then I'm going to go in order, I think, of each of these. All right, so if you want to graph them on here, you can. I've already graphed them, so I saved you the time of me not having to sit and talk about them the whole time as I'm graphing. So I've already done these problems. So we're going to go through each of these. All right, so I'm just going to talk you through them. All right, so bear with me here. All right, so here's our first problem on our study guide, -2 over x. So the first thing I want to do is I want to find what are the x and y intercepts. Okay, so what you need to know is when you find the x and y intercepts, remember if you want to find an x intercept, you put a 0 in for y. And if you want to find a y intercept, you put a 0 in for x. So look here, if I were to take this problem and put a 0 in for x to find the y-intercept, that would be a -2 over 0. Well, if you have 0 in the denominator, that's undefined. So we're going to come over here, and that's why I have over here, we do not have an x-intercept, which just means your graph is not going to go through the x-axis. Okay, so for a y-intercept, if I put a 0 in for y right here, okay, I would have 0 equals a -2 over x. Okay, if I did that, notice that if I'm going to solve this, I would multiply both sides by x, and it's 0 equals a -2, which is not true, right? So we're not going to have a y-intercept either. But let me just give you a hint, and you might want to write this down in your notes. To find the y-intercept, you can just set the numerator equal to 0. So I can just set this equal to 0, and that's what my answer is going to be. Because if you notice, I'm always going to cancel this out, and this is always going to be multiplied by 0. So just set your numerator equal to 0 to find your y-intercept, okay? So that means it's not going to go through the x-axis, it's not going to go through the y-axis. Okay, now let's look and see what is our vertical asymptote on this. So I don't have it written over here. So let's look at a vertical asymptote. So I just use VA for vertical asymptote. That means we're going to set the denominator equal to 0. So that's going to be x equals 0. So if I were to graph x equals 0, that is this y-axis. That's x equals 0. So that is an asymptote right here. Okay. Well, now let's see, do I have a horizontal asymptote? Well, I do not have an x value up here. So that means it could be, I always just kind of pictured if I don't have one, then that's probably x to the 0, right? Because x to the 0 is 1. So that's telling me that this is 0, this is 1. So this is larger than this. So if this power, which is a 1, is bigger than this power, then we have a horizontal asymptote at y equals 0. So this is y equals 0. So it has a horizontal asymptote which is the x-axis. Okay, now I'm just going to erase this on here because I'm going to use these notes again later. All right. So, so now we know our graphs, they can't cross the y and they can't cross the x-axis. So what we need to do then is, now I did a whole set of tables here. You don't have to do that. I just need you to pick. So we have this section over here, and it either has to be up here or down here. So pick a point over here. So I might say, let's just pick -3. Okay, I didn't do that one. Let's do -2. So I pick -2, and I put it in right here. -2 divided by -2 is a +1. So I know that -2, 1 is going to be on the graph. Okay. That's enough for me to be able to draw this graph to say, okay, well, I know it can't go past this because that's an asymptote. So I just draw it as it gets closer and closer. And I know it can't go past this because it's an asymptote. So I just know it's going to get closer and closer and closer. And keep in mind that it's a sketch, right? So we're good with that. Okay, well, I have another section over here, and I don't know if it needs to go up here or down here. So let's look and pick a point over here. So let's say I pick +2. Well, +2 gives me a -1. If I put a +2 in right here, then I would have a -1. So +2, -1, here's that point. So what I know is my graph's going to come down here and get closer and closer to the asymptote here. And it's going to go up here and get closer and closer to this asymptote, but never touch or cross them. And that's your graph. Okay. So if I were to look at and see what is the domain? So let's just look over here. So we start over here at -infinity, right? And this goes and goes and goes, but what does it never quite hit? It goes to 0, but it will never touch it. So we go from -infinity to 0. Okay. We also have here solutions here that begin at 0 with a parenthesis because it doesn't touch 0. And it goes here all the way to +infinity. Okay. Now let's look at the range. So we start down at the bottom. Okay, so we're going to start down here and we go up. And so we start over here, we're going to start at 0. And then we're going to go up. And so that takes us from 0 to +infinity because this will continue to go up higher y values all the way to infinity. Okay. And then we start here. Okay. And so this is going to start down here, all the way down here at -infinity. And it's going to come up and it's going to get closer and closer and closer to 0, but never touch it. So -infinity to 0. All right. So we don't need this on there. All right. So I just made this. I would not ask you where it's discontinuous, but notice if I pick up my pencil, I have to pick up my pencil to get to the graph, and it's discontinuous at 0, at x equals 0. All right. That's not a question I'm going to ask you, but I just want to be sure you kind of understand that. All right, let's do some more. Okay, let's take a look at your next problem. This is the next problem that we have. All right, so 2 over x plus 1. Okay, so again, this is very similar to this first one, really. So the first thing we're going to do, let's look at our intercepts. So if I want to find the y-intercept, I put a 0 in for x. So if I put a 0 in here, that's going to be 2 over 1. So y equals 2. So I have an intercept, x-intercept. Let's see, I did a y-intercept at 0, 2. Okay, you can read that, it's kind of written small. Now let's look at an x-intercept. So I put a 0 in for y right here. This is going to cancel out, so I just set these equal to each other. 2 equals 0. Okay, that means that we do not have an x-intercept because that is not true. So we don't have an x-intercept. All right, let's look at a vertical asymptote. So vertical asymptote just means we take this denominator and we set it equal to 0. All right, so we have, for the vertical asymptote, how we found that is x plus 1 equals 0, and that becomes x equal to -1. Okay. Now let's look at a horizontal asymptote. It's the same as up here. There's not an x showing, so I kind of think of that as an x to the 0, right? So if I have an x to the 0 and an x to the 1, if this one is larger, then I have an asymptote, horizontal asymptote at y equals 0. Okay, so let's draw those asymptotes. So here at -1, I have a vertical asymptote, so that's where this dotted line is. And then I have y equals 0, which is just going to be here, which is going to be your x-axis, will be the other asymptote. So those are the lines that won't cross. So I'm going to look over here. I'm going to see, I need to pick a point over here so I know if it's up here or down here. Obviously, you know, because you have the graph shown to you. But let's pick, and again, you can pick any number that you want over here. So let's pick maybe -3. So if I pick a -3 and I put it in right here, -3 plus 1, right, is a -2. So 2 over -2 is a -1. So I know that -3, -1 is part of that graph. All right. So I'm going to go ahead and I can draw this then. I can sketch it. I know this gets closer and closer to this asymptote, and this gets closer and closer to this asymptote. All right, then I got to look over here. Okay, well, I know it's got to be up here or down here. So pick a point. So 0 is kind of a nice point that I could pick here. So if I pick 0, I couldn't pick 0 up here because it's the asymptote, right? Oops, up here, I couldn't pick 0 because it's the asymptote. But down here, my asymptote's over here. So I'm going to pick this point right here, 0. So if I put a 0 in here, it's going to be 2 over 1, which is 2. So 0, 2, I know, is on that. So then just with that one point is all I really need, and I can continue to graph that. Okay. So let's look at the domain. So always starting over here, the domain goes from -infinity, and it gets closer and closer and closer to this point, which is -1. It doesn't ever touch it, so that's why we have a parenthesis. Okay, or over here, I start at -1 with a parenthesis, and I get continues on and on and on to positive infinity. Okay, this is a -1 because it goes from -1. Okay, so let's look at the range. So on our range, we're going to start down here, and we're going to work our way up. So we start down here at -infinity, and we get closer and closer and closer, but we never cross 0. So here's our range. Okay, or I start here at 0 and I continue up all the way up to positive infinity. Okay. And in this case, notice that this is no longer continuous, and it's discontinuous at x equals -1. Like I said, just want you to recognize that. Okay. All right. So let's continue on. I think we're still on still looking at your notes here. Yeah, 1 over x squared is your next problem. Okay, so 1 over x squared. So let's first of all talk about finding the intercept. So if I want to know the y-intercept, I put a 0 in for x. Let me move my camera here a little bit. There we go. So I put a 0 in for x to find the y-intercept. So it's 1 over 0. So that's undefined. So we are not then going to have a y-intercept. Okay, if I want to find an x-intercept, I put a 0 in for y and set it equal to the numerator, because this will cancel out. So 0 equals 1. So that's not true either. So that means I'm not going to have an x-intercept, and I'm not going to have a y-intercept. Okay, let's look at the asymptotes. So vertical asymptote. So if I take the denominator and set it equal to 0, that's going to be x squared equals 0. So I can square root both sides. This has a plus or minus. X is equal to 0. All right, so that's going to be your vertical asymptote on this one. So vertical asymptote, I don't have it written over here. Vertical asymptote is x equals 0. All right, so think of this as an x to the 0 power because there's not one showing. This is larger than this. So we're going to have a horizontal asymptote if this is larger than this power at y equals 0. So that means our axes are going to be our asymptotes again, like our first problem. Okay, so let's look over here and see, let's pick, we need to know if it's up here or down here, so let's just pick a number. So let's pick -1. How about that, -1? Because it's got to be here or here. So -1, if I put a -1 in here, -1 squared is 1. Okay, so that's going to be 1 over 1, which is a positive 1. So -1, 1 falls on that. So that's all I need to know. It gets closer and closer and closer to this asymptote, and then it gets down here and it gets closer and closer and closer to this asymptote, right? Okay, so now we also have to look over here. So let's pick a number over here. How about we just pick, doesn't really matter, we could pick since this is our asymptote, anything to the right of it, so how about 1? If I put a 1 in here, 1 squared is 1, so 1 over 1 is 1. So that's what this is right here. So 1, 1 falls on our graph. That's all I need, because I know it gets closer to the asymptote, closer to the asymptote. Okay, so let's look at our domain. If we start over here, remember our domain are our x values, negative infinity, and it gets closer and closer and closer to this asymptote, which is 0, but it never equals it, so that's why we have a parenthesis. Okay, or we can go from 0, right, from here, and it's going to continue on to positive infinity. Okay, let's look at our range. So our range is the same for both. It starts at 0, right, and then it just goes up to positive infinity. So range is 0 to positive infinity. Now, could you tell me where it's increasing and decreasing? You could, because here is where we increase, here's where we decrease. I'm not going to ask you those two things, but they might on your homework assignment. I can't recall if that's on your homework assignment or not. So if I look at where this is increasing, this is going up, 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 up. Okay, so from negative infinity to positive to 0, because it gets closer to 0. And then here we go from 0 and it goes this way. So 0, this is where it decreases from 0 to positive infinity. Discontinuous at 0. Again, I won't ask you to discontinuous. All right, so I'm not gonna do the next one. I'm gonna let you do that, but I'll have it on the notes right there, the domain range, the vertical asymptote. So I don't have that on here. So let's look at the vertical asymptote. If I take this denominator and I set it equal to 0, I'll let you figure that out, but you're gonna end up and see if you can get this answer, okay? And then your horizontal asymptote, there's not gonna be one. There's not a horizontal asymptote on that. I'm sorry, I was looking at the intercepts. This is gonna be a horizontal asymptote of y equals 0. Okay, so see if you can do this. It's very similar to this problem. You can even see the graph, but try and do it, okay, without looking at the answers here to see if you can do that. All right, because it's very similar to the other one. I don't want to continue to repeat the same problems. All right, so let's move on to some of the problems from 5.2. So these are your 5.2 notes. Let me grab them over here in my note pile. All right, so your 5.2 notes, and I apologize, I hope it's not too sloppy on here for you to see it, but it takes such a long time to write all these out. So let me go ahead and write these out because I feel like this is really sloppy. All right, so here we have f of x. Sorry if that's on the microphone, making it loud. So let's start with this one. I'm gonna take that down just a little bit. There we go, oops. You can still see that, all right? Okay, so if I'm just starting with that, let's start with the very first thing and talk about where are the x and y intercepts. All right, so let's look at an x-intercept. So x-intercept, we put a 0 in for y. So I'll show that to you just so you see what's going on here. And we just set it equal to the numerator because these are going to cancel out, right? If I multiply this times x minus 3, they cancel. If I multiply this times x minus 3, it's always 0, so that's always going to be 0. So all we do is set the numerator equal to 0 and then solve it. So that's going to be -1 equals 2x, and x equals a -1/2. So x-intercept is -1/2, 0. Okay. So let's look at the y-intercept. So the y-intercept is putting a 0 in for x. So y is going to equal, so if we solve that, that's going to be 1 over -3. So y equals 1 over -3. So the y-intercept is going to be 0, -1/3. Okay. All right, let's talk about then the vertical asymptote. So I'm gonna come over here and do the vertical asymptote. Vertical asymptote is taking the denominator and setting it equal to 0. So that's going to be x equals 3. Now let's determine if there's a horizontal or a slant. So these, in this case, these have the same powers. These are 1 over 1. So if it has the same power, then we take the ratio of these coefficients. So there's really a 1 here that's not showing. So our horizontal asymptote is going to be y equals whatever this ratio, 2 over 1. So y equals 2. So let's look at finding the graph, taking a look at what the graph would look like here. All right, so let's sketch a bear with me here. Guess I could shut that off. All right, so let's take a look and let's draw an asymptote. So if x equals 3, so 1, 2, 3, x equals 3, we know that. So that's our vertical asymptote. Okay, I don't need to go that far. And y equals 2. So y equals 2, that's our horizontal asymptote. Now I do know, because I found the intercepts, that at negative 1/2, 0, I'm going to have a graph go through there. And then I know at 0, negative 1/3, I'm also going to have a y-intercept at 0, negative 1/3, which is somewhere in here. So that really tells me, at least as far as where to go here and here, I know my graph is going to be somewhere. Like I said, it's a sketch, so it's okay, something like that. But then what I have to determine is over here, if I want to do a few more points, is my graph going to be up here or is it going to be down here? So let's pick a point here. So 1, 2, 3, how about 4? Hopefully that'll turn out to be a decent number, I don't know. So let's put a 4 in right here. So we have 2 times 4 plus 1 over 4 minus 3. See what we come up with. 8 plus 1 is 9 over 1. So I know that point 4, 9 falls, gosh dang it, 4, 9, sorry about that, falls on the graph. So we're going to go over to 4, 2, 3, 4, and we're going to go clear up here to 9. It's going to be way up here. All right, but it goes off my graph. So 4, 9 is way up here. So, but what we know is it's going to go up in that section of the graph. So that's what our graph would look like, something like that. So let's look at a domain. Let's always start from the left, right? So we come over here and we're going to go from negative infinity. And then where does it get closer and closer and closer to? At x equals 3. Okay, or I have solutions over here that begin at 3, right? They begin at 3 and they go to positive infinity. Okay. And then the range. So let's start down here at the range. We're going to go down here from negative infinity. And it goes up to, where does it stop on the y? At 2. Or it's going to begin at 2, right? Begin at 2 and continue up to positive infinity. All right. So let's take a look at the next one on your notes. We're just doing a few more examples, maybe 2 or 3 more here, just so you get a good feel. Okay, so here is f of x. I think this is the next one on your study guide. All right. Notice this does not factor. It's not a -1. It's not a difference of squares, so that does not factor. All right, so let's take a look at the x-intercepts first. X-intercepts. So if we want to know the x-intercepts, we put a 0 in for y, right? And we're just going to set the numerator equal to 0. So that becomes x squared equals, I kind of flipped it around. I just put a -1 here. I just put my x squared on the other side. Oh, so if I square root this, what's going to happen? We're going to have, what's the square root of remember it's a plus or minus. What's the square root of -1? Well, that is going to be a plus or minus I. All right, so what that means is we're not going to have an x-intercept on that. I mean, it's a plus or minus I, that's fine. It just means it's not going to go through the x-axis. So that means that my answers are not going to cross the x-axis. Whenever you have an I, that's a complex number, remember, and it doesn't cross the x-axis. All right, so let's look at the y-intercept. So the y-intercept is putting a 0 in here, so changing the f of x to y. So y equals 0 squared plus 1 over 0 minus 2. So that becomes y equals negative 1/2. Right? That negative can go anywhere on that fraction, remember. Okay, so let's look at a vertical asymptote. Vertical asymptote, set the denominator equal to 0. So x equals 2. And then let's check out our horizontal asymptote. So this time we have m, this is less than n. So we haven't had that before. So that's going to tell us that we're going to have a slant or an oblique. Okay. So what we have to do is, this is where our long division comes in case you've forgotten how to do that. I'm going to show you one. You got to divide the bottom into the top. So it's x minus 2. Now notice that I'm missing a term right here. So we have x squared plus 0x plus 1. So here, x squared divided by x, we're going to multiply back through and then subtract. Add down, bring down our next term. 2x divided by x is 2. Multiply back through. 2 times a negative 2 is a negative 4. Subtract. All right, so what we do on this is we just ignore, we don't care about the remainder. All we look at is this right here. So I'm going to write this as y equals whatever you get when you divide up here. And it's always going to be what we work with now. It's always going to be linear. So that means that when I graph this, it's just going to be a straight line. I mean, it has a slope, but it's going to be a linear line still, which makes it really nice. Okay. So let's take a look at the graph. I'm going to put the graph over here. Hopefully it'll stay on my graph here. All right, so for this graph, let's graph, first of all, we have vertical asymptote at x equals 2. So let's go to x equals 2 and draw a vertical asymptote. All right, then we're going to have this one. So all we do is graph this line. So make this a whole number, put it over 1. So we're going to start here, just using the slope-intercept form. So start at positive 2, put a point. Then we're going to go 1 up, 1 to the right. So 1 up, 1 to the right. We do that a couple times. And you can go backwards. My graph isn't super, and which isn't great, but it's not the best to sketch. So, all right. So that's a slant. That's all it is. And you can do that. You can graph a linear line, and you know how to divide. So that shouldn't be too bad for you. Okay. All right. From there, then let's figure out where our graph goes. So we have, notice we have these sections here still. This just has a slant, but we still want to check which section. But we can look at our intercepts. Our intercept, we don't have an x, but we have a y-intercept at negative 1/2. So negative 1/2 right here, we know our graph's going to go through there. I also know it's not going to go through the x-axis because of this, so I know it's not going to come up here. It's not going to go above the x-axis. So if you want to pick another number because you just want to be sure, you could, let's say maybe negative 1. How about we try positive 1? It's a little bit easier. Let's put a positive 1 back in here. So 1 plus 1 is 2. 1 minus 1 would be a negative 1. So that's going to be 2 over a negative 1, which is a negative 2. So when I put a positive 1 in, came up with a negative 2. So what that shows me is my graph's going to go somewhere here, and it's going to go here, and get closer and closer and closer to these asymptotes right here. Okay. Now let's look and see if it's here or here. So let's pick 1, 2, how about 3? It's going to be kind of a big number, but if I put a 3 in here, we have 9 plus 1 is 10, and then 3 minus 2 is 1, so 10 over 1. So when I put a 3 in, I'm going to be clear up here at 10. So really, I just know, and I don't know how far down here it's going to come, that's okay. You can just do a sketch here, something like that. All right. About, let's take a look at what the domain would be here. So do the domain over here. The domain, so if we're looking at our x values right on our domain, we're going to go negative infinity. over here, and it gets closer and closer and closer to this value, which is 2. So we're going to go from negative infinity to 2. Okay, or what do we have over here? So we start at 2, and where's it going to go? It's going to go to positive infinity with our x values, right? It goes to positive infinity. Okay, what about the range? What do you think we have for the range there? So let's see, we have our range. We're going to start at negative infinity, and it doesn't ever get up to x on that, right? Because we have complex numbers. So we would go from negative infinity to 0. Okay, or where are we going to go here? Well, I can't remember what. Actually, this one's kind of tough, right? Because we don't know what this number is. So when we have the slant, we probably won't do the range, unless I would have you do an exact graph where you'd have to pick all the points on it. Since this is a sketch, we're not going to be able to do the range on that because we don't know where this starts. It's a sketch, so we won't worry about the range on something like that. Okay. All right. Let's do one more. I want to do, or maybe, I don't know how much time we have here. Let's do 1 or 2 more. Sometimes these videos get kind of long, so they're. Let's do this one on your. I think it's on your notes as well. But this one will have a hole in it, so I want you to be sure that you see a hole on a graph. Kind of situate here. All right. So given this problem, so let's first of all, what you want to do first on here is if you can factor, you want to go ahead and factor. So if I look at this denominator, that's a difference of squares. And that's going to factor to an x plus 2 and an x minus 2. Okay. So what I can do here with these is I can, let me bring this in just a little bit. Let me bring it down just a little. Okay. Make sure it's focused. I don't know if that gets any better or not, but so what's nice here is I have a common factor on the top and a common factor on the bottom. So what I can do is I can cancel those out. So what I'm left with after that is 1 over x minus 2. And what's nice is I can just work with this now. I don't have to work with this. But I'm going to come back and I'm going to talk about this hole at x plus 2 in a little bit. But let's go ahead and go with our intercepts first. So let's look at an x-intercept. So if I come over here and I want to do an x-intercept, all right, so I have f of x equals 1 over x minus 2. I'm going to put a 0. I'm going to set the numerator equal to 0. So 1 equals 0. So I'm not going to have, there's no intercept for the x-axis. Okay, let's look at a y-intercept. If I look at the y-intercept, I'm going to put a 0 in for x. So 1 over negative 2. So that's going to be y equals 1 over 0 minus 2. Okay, so that gives us y equals a negative 1/2. Let's see about a vertical asymptote. Well, we take, after we've canceled out, we come over here. We take the denominator and set it equal to 0. So x minus 2 equals 0. So we have a vertical asymptote at x equals 2. Now, let's see if we have a horizontal or a slant. So this is larger than this. Therefore, it's going to be a horizontal asymptote at y equals 0. Okay, this is larger than this one, y equals 0. Now let's check out the hole, where the hole will be. So to do this, all we do is we take whatever the factor was, the same, it was x plus 2, and we set it equal to 0. So x equals a negative 2. So we're going to have a hole at negative 2. Now, I probably want to know what my y coordinate is there because it's an ordered pair that falls on the graph that I'm looking for. So just go back to this problem over here, and we'll just substitute in a negative 2. We'll evaluate it, put in a negative 2 for x. So when I substitute in a negative 2, I'm going to get 1 over negative 4, so negative 1/4. So what that tells me is my hole is going to fall at negative 2, negative 1/4 when I do the graph. So let's take a look at the graph. Okay. All right, so here's our graph. Let's go ahead and do our vertical asymptote at 2. So here's our vertical asymptote. Horizontal asymptote, it's going to be at y equals 0, so it's going to fall on the x-axis. All right, now I'm going to have a hole at -2, -1/4. So -2 approximately, -1/4, I'm going to have a hole in my graph. That means my graph's going to go through that point. All right, so let's check it and see the areas here, the sections, and see where they're going to go. So let's pick a number on this side of the asymptote. So how about 0? 0 is always a good one to pick if you can. So if I put a 0 in right here, so I'm going to have, if I put a 0 in, that comes out to be 1 over -1, which equals a -1. So at 0, my graph's going to go through -1. Okay, that's pretty much enough for me to go, okay, well, I know it's going to go here, and it's going to get closer and closer and closer to 0, and it's going to go here and get closer and closer and closer to x equals 2. I never touch that asymptote. Okay. Now let's look over here on these two sections. So let's pick one, maybe 3. Let's try 3. So if I substitute in a 3, we're going to get 1 over 1 equals 1. So if I put a 3, y value is 1. So 1, 2, 3, 1. So again, I can draw that. So let's see what the domain is. Domain goes from -infinity to 2, or it begins at 2 and goes to +infinity. The range starts down at -infinity, goes up here to 0, or it begins at 0 and goes to +infinity. So those are the things that I want you to be sure that you can tell me. So that's the only thing you do with a hole, and the only time you have a hole is if I can have a common factor top and bottom. Common factor top and bottom. That creates a hole. All right. All right, so let's finish with one more, because you might see something like this on your homework. I'm not exactly sure exactly what you're going to see on your math lab completely. Just trying to remember. I haven't looked at it for a little while, but so let's go with this problem right here. I don't know if you guys can hear my cats eating the cat food behind me, so I hope that's not too annoying. Okay, so here, here we're going to factor this out. Doesn't have a greatest common factor, so I have to use the AC method. All right, so let's go ahead and take care of that. So this times this is a -6. Multiply factors of 6, that will give us 5, but we have to multiply it. So let's try 6 and 1. How about a +6 and a -1? That gives us a +5, but it also gives us a -6 when we multiply it back together. Okay, I'm going to do the work over here for this. So we have 2x squared, and then we use these 6x minus 1x minus 3. Okay, we're going to split it. So we're going to take out a 2x here. 2x divided by this is x. I'm sorry, 6x divided by this is 3. That was a 2x squared divided by 2x. I said that wrong. Take out this sign. This divided by this is x. This divided by this is 3. So this is going to factor out to an x plus 3 times a 2x minus 1. Okay, so I know that's kind of quick, but that factoring part you should have down, or, you know, it's okay if you still struggle with it, but all right, but what I see here is that I don't have a hole, right? Because I don't have anything in common there. So does that do me any good to factor it? It still does, because you have to set it equal to 0 to find the vertical asymptotes. So you still have to factor it either way. So let's start with maybe the x-intercept. So x-intercept, we're gonna do x-intercept, we're gonna set the numerator equal to 0. So we have x equals a -1, right? Just subtract 1 from both sides. All right, so the y-intercept means we put a 0 in right here. So we would have 0 plus 1 over 0 plus 3 times 0, 2, excuse me, 2 times 0 minus 1. All right, so that leaves us with 1 on, whoa, 1 on top, and then this is 3 times a negative 1, a negative 3. So we have an x-intercept at negative 1, 0, and a y-intercept at 0, negative 1/3. All right, let's look at a vertical asymptote. Okay, so let's set our denominators. It's really nice. Now that we have it factored, we set each of our denominators equal to 0. So that would come out to be an x equals a negative 3. Okay, here I would add 1 and then divide by 2, so x equals a positive 1/2. So we have 2 vertical asymptotes. All right, so this is smaller than this, so that means we have a horizontal asymptote at y equals 0. So let's take a look at the graph. All right, so let's look at our vertical asymptote at negative 3. And I have another one at 1/2, so it's approximately right here, kind of to sketch, remember, so that's okay. So those are your vertical asymptotes. And then here is our horizontal asymptote at y equals 0. So now the only thing different from this is that we just have 3 sections that we have to look at. So let's take a look over here and let's pick 1, 2, 3. How about negative 4? And let's put in right here. I think it'd be a little bit easier to put in a negative 4 there. All right, so I'll see if I can squeeze this in. If I put a negative 4 in right here, I would have a negative 3. If I put a negative 4 in here, I'd have a negative 1. And a negative 4 in here would be negative 8 minus 1, negative 9. It's a pretty big number. So that's going to be a negative 3 over a positive 9. Okay, so that makes it negative 1/3. So when I picked negative 4, then I know negative 1/3 somewhere in there. So what I know from there is that my graph is going to go here and it's going to go here. Now let's look in here. Okay, now here we have to be kind of careful because we have a top and a bottom. So let's just see what we can find here. So what happens when we pick 2? So if I pick 2, we would have 3. 2 here would be 5. And 2 here would be 4 minus 1 would be 3. So that's going to be 3/15, which equals 1/5. All right, so when I picked, oh, did I do that wrong? Just a second. I needed to pick, what did I pick here? Did I pick a negative 2? Did I do that right? Bear with me here. I put a negative 2. I did a negative 4. Well, that's not going to work. What did I do? You guys, I picked a positive 2. Okay, so I picked a positive 2. So I picked this point over here. I think I was looking weird here. I was looking at this. But anyway, here's 2. So if I pick 2, then it's 1/5. So 2 is 1/5. And I know right here is an asymptote, right? So all I need to know here is that. Okay, now when I have my 2 asymptotes here, that does not, there's not an asymptote between these 2. It's just here on the outside. I don't have the asymptote here between those 2 asymptotes. All right, it's kind of like these block them. So I have this and I have this. So now let's find here where these might fall. So how about we look at, how about just a negative 1? Let's look at this point. So I'm going to come up here. Sorry, I'm out of room. If I put a negative 1 in here, I have 0. Oh, so it really doesn't matter what I have down here as long as it's not 0. I know that it's going to be 0. 0 over anything, right? Unless it's undefined, but that's not going to be undefined. So negative 1, 0 is 1. Okay, now let's see, what about if I use a negative 2? So if I put in a negative 2, negative 2 plus 1 is a negative 1. Negative 2 plus 3 would be 1. And 2 times a negative 2 would be negative 4, minus 1 would be a negative 5. So that's going to come out to be 1/5. So negative 2 and 1/5. Okay, so let's keep going. How about we try 0? Let's see what 0 does. So if I put a 0 in, I would have 1 over 3, 2 times 0 times -1. So -1/3. So if I put 0 in, it's a -1/3 somewhere in there. All right, so what that tells me is that this is going to look kind of like a cubic chair equation. It's going to go something like that. It could have went something like this, the opposite way, all right? So that's probably the most difficult problem that you will see. And it's not too hard, it just takes a little bit of time and a little more paper than I allowed. Okay, all right, you guys. I'm sure you're tired of listening to me talk. I'm sorry, that was a lot to talk about. But I have 4 problems I'm gonna post in Pages, View All Pages, so be sure you look at, you have a little time on this, so work on it so that we can talk about it when we have our open discussions, all right? And I don't think that one is for a little while when we discuss this, so you have a little time to work on it. Stay on top of your math lab and have an amazing day. All right, see ya.